Good morning, ladies and gentlemen. Welcome to today's virtual visit on Experiment Power Grid Center, or short EPGC webinar. This event is jointly organized by Singapore Water Association and Smart Grid and Power Electronic Consortium Singapore, for short, SPECS. Before we kickstart this event, I would like to share with you the following. Housekeeping. To ensure a smooth session, please mute your microphone and turn off the camera. You may communicate with us after the event. Please share your questions in the chat, where we will try to provide answers where possible in the Q&A segment. Do identify yourself so we can respond to any answers questions. We'll be recording this session and reserve the rights to the video. Please complete a post-event survey. Upon return, we will forward the recording and presentation deck to the respondents. Disclaimer. All information shared is for general information only and does not contain or convey any legal advice or administrative assistance. Information shared today is true and accurate as of publication date. SWA and SPECS reserve all rights in the provided materials. Now, I would like to invite Dr. Adrian Yeo, who is the Council Member of Singapore Water Association. Dr. Adrian is also the Senior Vice President for Innovations Water from Sembcorp Industries Limited. Over to you, Dr. Adrian Yeo.
Very good. Thank you, Dr. Marcus Goh. Ladies and gentlemen, a very good morning. I'm honored to be here today to welcome all of you to this virtual site visit jointly organized by the Singapore Water Association and the Smart Grid Power Electronics Consortium Singapore. Despite the challenges posed by the pandemic, we have been working closely since February 2020, coordinating in how we can support our members through knowledge sharing, network opportunities, and partnerships. SWA and SPECS also work closely with key stakeholders to align our directions in R&D, and we are planning for a joint masterclass workshop in November 2020 on solutions for energy efficiencies in the water cluster. In such COVID times, it is therefore timely that SWA and SPECS step up support to organize this virtual visit to the Experimental Power Grid Center, or EPCG, to understand how EPCG can support the R&D and deployment of solutions for the energy grid. Started in 2004, SWA is a platform to build effective networking, facilitate opportunities for collaboration, and foster the exchange of ideas and knowledge among member companies. Our mission is to develop a vibrant and dynamic Singapore water industry with the vision to be the regional hub for all water services and technologies. SWA also actively connects to the global water network through setting up Singapore pavilions at overseas trade shows, overseas missions, and with business seminars. Our current 260 members comprise a diverse mix of both local and international organizations, commercial companies, research institutions, SMEs, and startups, which constitute the entire water value chain. COVID is significantly impacting our health, lifestyle, business, and economy. SWA is working closely with our members to help mobilize, stabilize, and resume operations with our SG United updates, SW Assist, S-Watch initiatives, as well as other regular updates. We also launched the SWA Marketplace Assist platform, SWA Map, for our members who seek to connect with other fellow members and partners. More information can be found on our SWA website, or please contact any of my fellow colleagues from SWA to find out more. SWA is also working with the Singapore Business Federation, Enterprise Singapore, Skills Futures Singapore, and E2I to assist local companies for job retraining as well as the creation of new business. Singapore has a great reputation as a global innovation water hub, and it continues to grow through the efforts of PUB as well as other government agencies such as the NRF and Enterprise Singapore. SWA would like to encourage more of our local companies to take advantage of this strong R&D system to develop proprietary and innovative technologies, as well as solutions that will make your businesses more competitive and resilient. Today's session is one such opportunity where SPECS is able to help companies access latest technologies developed by them and to translate them into commercially viable products and services. In closing, I look forward to seeing some new partnerships established from today's session, and do allow SWA and SPECS to contribute to the growth of your company. Last but not least, if you are already a SWA member, I would like to thank you for your support, and feel free to let us know how we might be able to serve you better. If you are not a SWA member, we would like to welcome you to join our SWA community by contacting one of my colleagues or visiting the website. I hope you will enjoy today's virtual visit. Thank you very much.
Okay, thank you very much, Dr. Adrian Yeo. Now it gives me the pleasure to invite our guest speaker, Dr. Marcus Koh from SPECS, to give us an overview on the Experiment Power Grid Center Megawatt Scale Grid facility. Over to you, Dr. Marcus Koh.
Okay, thank you, Jess. Hi, good morning, ladies and gentlemen. First of all, thanks a lot for the Singapore Water Association for inviting the Smart Grid and Power Electronic Consortium of Singapore, in short SPECS, to share this virtual tour with all the members of SWA and the public in general. So first, I would like to acknowledge all the effort put in by SWA members as well as the SPECS Program Office for making this virtual tour possible. So without further ado, let me quickly go through the sharing for this virtual tour. So let me see if I can get a pointer up. Okay, so this will be the 4 parts that I will run through today for this virtual tour. Is to first give an introduction of Experimental Power Grid Center, or EPGC, followed by talking about the facility, then the capabilities and use case for sharing. And then we will end up with a question and answer. So what is SPECS all about is, SPECS is actually supported by the 4 government agencies that you see here, which is the NRF, National Research Foundation, Economic Development Board of Singapore, Energy Market Authority, as well as Enterprise Singapore. So this is a national consortium that actually has all the partners from A-Star, NUS, NTU, the universities here, Polytechnic, as well as ITE. So the key goal for SPECS is to unlock the research investment and help companies in Singapore to do commercialization projects in the smart grid and power electronics area. All right, and we hope to be able to support the local companies and to gain so that they can have competitive advantage and go to the region and beyond. So a very brief overview of all the SPECS members. It comprises of a large local enterprise, the multinational companies, our local SMEs and startups, and of course we are affiliated with SWA, the Singapore FinTech Association, and the other consortium like the Coolest SG Singapore Battery Consortiums in Singapore. So with that, I will quickly run into NTU, where the Energy Research Institute, all right, is actually hosting SPECS Program Office. So in the case of Energy Research Institute at NTU, or in short, ERIN, there are 3 areas of focus that is looking into energy system, primarily the renewables and energy storage. And we also look into the grid system, which is looking into the future grid, which is Energy Grid 2.0, or in short, an Internet of Energy. So when we talk about grid system in this case, we are talking about energy grid, which is electricity grid, thermal grid that's related to water, as well as gas grid. So it's just not just an electricity grid, so to speak. And eventually you'll go into the end use in the urban solution, that it talks about smart energy, the last mile and the first mile for mobility. And more importantly, today's topic is about industrial energy efficiency. So with that, what will be the goal for all this mid to high technology readiness level, investigation is mainly about system level integration and we search for a tropical mega city that will make sense for Singapore businesses. And with that, we are happy to share there are various living labs that has already been incorporated. And today we are specifically looking at the Experimental Power Grid Center, EPGC. So what exactly is EPGC? It's actually located on Jurong Island, and it's actually a facility in megawatt scale that is meant for equipment manufacturer, system integrators to test the technology at an actual power before deployment. So that's why it's actually in the domain of energy. And when you say energy grids in this case, again, I would like to emphasize it's not just electricity grid, but includes thermal and gas grid as well. And definitely thermal is part of where we will classify water as part of it. So there are various industry partners that have already been working together with EPGC in the past, and we look forward to more interaction with the SWA members at large as well. So with that, I'll run through a 2-minute virtual tour for EPGC. Just give us a minute. We'll run through a 2-minute virtual tour. Okay, there's a quick virtual tour for the experimental power grid, which is actually a megawatt facility, not only for electricity grid, but it includes thermal grid and gas grid as well. Okay, so the part 2 of this, we'd like to go into the facility for EPGC to go a little bit deeper on what are the equipment that the companies in Singapore could capitalize on some of this test, verification, and certification equipment. So with that, I think the first and foremost is the hardware and software in the loop that is using a real-time simulator. This is something that has already incorporated in the system. So in the case for an energy system, it needs to work in microsecond or millisecond time domain, where first, primarily we are focusing on the power domain. That's actually a simulator that is able to support all the power electronics development. And eventually when it goes into seconds, minutes, or hour, that is where it's in the energy domain that will look into the energy management system. So the purpose of this is to help companies to lower their costs, lower their risk, so they can have a rapid evaluation at a low-risk environment to explore the instability and problem for solution, innovative solution before going through the implementation phase. So these are the equipments that are currently installed in EPGC itself at a megawatt scale. So from the power grid to the power grid simulator that is able to do not just a one-directional power flow, but includes a bi-directional power flow that can go back to the grid. And there are emulators by the wind turbine, solar PVs. And of course, we also have the actual solar PV that's able to connect to the sun. And things like the line impedance itself, it allows you to emulate transmission line that could be in hundreds of kilometers that is never going to be possible in Singapore. And there will be a low voltage grid, switching grid itself that facilitates multi-connection to all the source and loads. So you've seen that there are 3 units of diesel generator up to 250 kVA can also be connected to this experimental power grid, whether it's in an off-grid environment or on-grid environment. Now, on top of that, I think back at that time, about 10 years ago, it was already designed with a mixed chemistry of energy storage solution, be it lead-acid, lithium-ion, or ultracapacitor bank, has already been designed into the system. And then things like the programmable load, it could be an industrial load, HDB, or residential load, that can be emulated within this system. And this is a highly flexible and reconfigurable system from the control room to have all this power equipment and mimic it like a real lifelike system. So a brief overlook at what EPGC now is the backbone is actually an electricity grid, but it's also coupled to a water or thermal system, all right, for energy recovery that you have seen in the video, so that you will be able to behave like a green building or a district cooling system that will be pumping water, chill waters in different directions, and you can evaluate the industrial energy efficiency. The mixed chemistry that I was talking about allows the energy storage test platform to be evaluated and tested at this platform up to 200 kilowatts for all kind of chemistries that a battery can imagine. And that goes with the power converter developments that allow not just unidirectional power transfer, but includes bidirectional. So the solar inverters or energy storage converters, these are things that will be built, developed, and tested, and eventually could be certified in this location. And we're also happy to share that this motor test bed here that allows a motor generator to be explored with a variable speed drive or VSD up to 0.5 megawatt of test bed that can be evaluated in this site. So with that, I think we're happy to share that we have signed up with various certification partners at different stages of this journey that allow this testing and validation site now to have a certification partner can endorse the power equipment products or things that are in the energy grid domain to be certified by different partners that you see here. So with that, we are also happy to share once the experiments or the testing, validation, and certification has completed in EPGC, we'll bring it to Semakau Island, where there's a living lab called the Renewable Energy Integration Demonstrator of Singapore, in short, REITs, so that we can do deployment, like you see the solar panels and the wind turbine that is already available on Semakau Island with a hydrogen vehicle for refueling. So all this new technology can be deployed and tested in an off-grid environment to contain the risk that it could expose to the main island. All right, so this is where we see ourselves, where the university will do the low technology readiness level in a very early stage. And eventually, when those technology is ready, like what Dr. Arian Liu was talking about, we will bring it into a mid-technology readiness level at a megawatt scale to test at EPGC. before we bring it into a large megawatt test platform like Semakau Island in Reeds or in Jurong Port that we are currently implementing a smart multi-energy system. So with that, I would like to share on capability and use cases as an example. So this is a airflow simulation. The NTU is happy to share that this is a project that we are working together with HDB as well as an architect EDDP. So this project was actually to certify Pongo waterway, pre-lodge at Pongo as well as Bidadari area. We would like to understand the last 10 years of airflow, the sun angle, the irradiance, so that we can actually predict and optimize virtual natural ventilation for a housing development board apartment. So not only that we look at the pristine airflow, but that include a micro simulation within the apartment itself. All right. The outcome of that was that we're able to achieve 75% of the unit within Pongo waterway to have an optimized natural ventilation, and 83% of that within the tree lodge as an optimized natural ventilation, so that it will reduce the energy intensity of Singapore and starting from Pongo itself. So the outcome for this airflow simulation, where we look at the initial design and the improved design, all right? So we're happy to share as well that before and after, we're able to recommend like to decrease the building height in this area or separate one unit into 2 blocks, all right? And some other areas will increase the building heights. So the design improvement basically allowed some of these areas to be given a Green Mark Platinum by BCA. So with that, after learning how to do an airflow simulation, we're happy to share that we will be able to do a water simulation as well, to do an assessment in this area, because by just changing the partial differential equation, that we'll be able to do water without much difficulty in the same area. So the next project we'd like to share is a portable solar PV, as well as a solar thermal using a membrane distillation of seawater desalination. So this is a technology that is an off-grid solution that is fully zero carbon by itself, that is basically just using solar and solar thermal to power this container in NTU, and eventually is to convert salt water into drinking water daily so that it can be deployed in Riyadh in Saudi Arabia. So this is a successful project that has already been deployed, and the customer has already accepted the solution. So the key innovation behind it is really about a membrane distillation technique as well as the system level integration. So the next potential project we'd like to talk about that could be applied in EPGC is on a dock pumping application, where you will have things like a ship that you need to fill up eventually after the service overhaul or the construction, that you can fill up the dock with water or you drain it out. So by doing that, it requires you to have a variable speed drive, a motor, and a pump. And you need to recirculate this within the dock itself, and that would be something that the existing equipment in EPGC will allow testing, validation, and certification of the motor drive or pumping application, and also assess the industrial energy efficiency for companies in Singapore. So this is another potential area which is in the floating PV for fish farm. There are at least more than 150 fish farms all around Singapore in the northern island and the southern island of Singapore. So I think the space in the sea will allow us to install and evaluate all these saltwater floating platform. Of course, we would like to know whether there will be biofouling from all these floating platform. 2, it also allows us to assess whether we can use a bifacial solar PV, all right, to harvest more energy from the sun itself, At the same time, it will feed not just the smart fish farm as a load, but the excess energy could be stored into a floating energy storage system, or ESS. And if there is still excess energy beyond the ESS, what it can store by itself, we will possibly be able to put it into a hydrogen generator and bring it back to the main island as a hydrogen energy. So this is an example that talks about the floating PV system with the smart fish farm and the energy storage before it comes back as a hydrogen storage. And that would mean to say that it requires an advanced energy management system from the scientific committee here to assess how can we balance the supply and demand. So if we do have excess energy, eventually the advanced energy management system will be able to plug in and bring it as hydrogen storage back to the main island for Singapore usage. So with that, we are happy to share that from the university research that is already available in NUS, NTU, SIT, A-STAR, etc. at low technology readiness level. It is ready for deployment in EPGC at megawatt scale at a mid technology readiness level, and eventually going to a large scale megawatt project in Semakau or Jurong Island, etc. So I would like to touch on what could be the water energy nexus for deployment opportunity in Singapore, so that we can see those opportunities that will also drive industrial energy efficiency. So this is an article that was published just about 1-2 weeks ago in the Straits Times, talking about TWAS nexus. And he also articulated that there are some opportunity for integrated waste management facility, IWMF, all right, for Singapore. So what we could, all right, contribute to the industry and Singapore, in this case, on industrial energy efficiency could be in these few areas that we like to share with all the members here today from SWA as well as SPECS. So this could be one of the co-simulation platform between the water grid and the electricity grid that we can actually link up the computational fluid CFD analysis as well as the real-time simulator for electricity grid. So there will be a potential to build a planning tool for optimum sizing for a water grid and electricity grid in combination with information exchange. And the goal for this is really about assessing water energy cost savings, water energy savings as well, and eventually a carbon reduction. So this planning tool will allow us to do an assessment before building up the actual system, or it could be a greenfield or a brownfield assessment as well. So with that, there is also an opportunity for the integrated waste management facility to look into a cyber-physical simulation platform to enhance the resiliency of the IWMF. So what you see here is the integrated waste management facility, which is a physical system, but the sensors and the valves could be streaming data into a virtual system, which is a digital twin in the cyberspace. So with the real-time simulator platform and the real-time data that is coming through the controller itself, feeding the right data into it, we could make the system more resilient without impacting on the actual operation of the integrated waste management facility, so that the system can be assessed to be more robust to protect the system, that eventually will increase the resiliency of water grid as well as electrical grid in Singapore without actually impacting on the system, but we can build and study the system to increase the resilience in that. So with that, I would like to look into a different area, which is the industrial energy efficiency opportunity from the motor drive. And you can see that with every time when we have integrated waste management facility, there is always an electric prime mover or motor with some kind of a VSD installed, and it will always take energy from the power grid. So this has always been power and energy flow from one direction from left to right. So with that, today it's becoming possible to have a bidirectional power flow when the prime mover is regenerating and it can put energy back into the grid. But instead of going all the way back to the grid itself, it could be used for air conditioning, the lighting, etc., other loads that is within the vicinity. So this is what we call the regenerative energy. So this is a technique that is possible today thanks to the power electronics on the variable speed drive of VSD itself. So that means to say that if we look at the component level in a water treatment facility, for example, you basically have an electric motor and you have a VSD or VFD with some kind of PLC control. So we can look deeper into the component itself, like the variable speed drive or variable frequency drive. So for all motor itself, it comes with the real power as well as the reactive power. The real power is what we want, which is in kilowatt, and the kVAR, the reactive power, is something that inherently comes with it. So having more reactive power, potentially that means to say the end user will need to pay more money because it's actually having a poor power factor. So what we are like to introduce is there will be opportunity like an advanced active filter or an active front end from a power electronic perspective that you see here that could help to improve on power factor, reduce harmonics, or else the system could go, unstable every now and then, causing more heating and a shorter lifespan of the power equipment. And there's also an opportunity to do a power regeneration. So thanks to the active filter as well as active front end today, this technology is already available today to allow us to improve on all these power quality issues so that we can, save costs from using some of this technology. So with that, there is something very simple that we also like to share, which is a cooling consideration. All right. So this is a typical way that the industry has used in the past and is still using today. That is, all the heat load is cooled by the aircon mechanical ventilation in general, or which is an ACMV. So the power electronics as well as the low voltage electronics is all cooled within the room itself. So that will incur more efficiency losses versus a cooling that is doing the outdoor cooling for the power electronics itself, and the indoor cooling is for the low voltage electronics by doing a dual side cooling that allows a cost savings. So if this is designed properly by the end user or consultant, and this is just a case study reported by the industry, that they could save up to 53% potentially just by doing dual side cooling instead of doing a traditional cooling that you typically will see. So with that, looking at the component, not just as a VSD, but include the energy efficiency for the prime mover. So I think this is an area for application that we have been looking at and looking into the security of the prime mover and eventually the speed control. It could be a fixed speed motor or a variable speed motor generator. But what we like the audience to be aware of, there are also selection on the IE of this motor, where IE4 is one of the most efficient electric motor in the industry that it could actually leverage on that. It can go up to an efficiency of 97%. And then before you consider the ingress protection, which is the IP, from low IP, which is more susceptible to dust, as well as water versus the IP 55, 65, 67, that it has a higher ingression protection against water, dust, and vapor. So these are areas that could be considered by the industry. If the selection is on more efficient prime mover, then perhaps a higher level of IE motors, like IE3, IE4 motor can be selected. So with that, there is also another simple case, for example, like a motor drive energy efficiency for a fan load, for example, to be considered. So if you look at the flow rate of a fan, like at 50%, an ideal fan would take about 10% of input power. So if the user would apply the pink curve, which is actually the eddy current coupling, at 50%, it will require about 30% input power. So the delta that you see between 30 and 10% of the input power is actually the losses. So with that, you can see that it could be a very simple and traditional solution using the eddy current coupling to drive an ideal fan control. You actually incur more losses as you increase the power flow. So that means to say that the gap that is closest to the ideal fan curve, which is the minimum losses, is actually using some kind of variable speed drive or in general electrical drive, so that we will be able to operate 24/7 at the least loss in the system. So this is a very simple matching between the source, the supply and demand, so that we can minimize the loss in the system. For this case, we are looking at a component of cost. So with that, we are happy to share that with the integrated waste management facility, which is a smart water energy nexus deployment, what could be the opportunity? So like what we are showing in the virtual tour, there is already a deployment, not only in Samakau in REITs itself, but includes Jurong Port, where there's an optimization where the control center can see the solar, the combined heat and power, the AC/DC grid, the building management system, the energy monitoring system, the sensors that are streaming in. So we'll be able to do an optimization for a water energy nexus like the IWMF. That will allow Singapore to lower its energy costs, as well as to look into energy savings opportunities. And eventually it will lower the CO2 footprint of Singapore and make this a more sustainable environment for all of us. So with that, we're happy to take any question that may come along. Thank you.
A big thanks to Dr. Marcus Goh. Thank you for sharing with us on these interesting topics and virtual tour. We have come now to the question and answer segment, and this will be moderated by Dr. Marcus Goh. If you have any questions, please put on the chat with your name and company, and for which speaker, of course, Dr. Marcus. So participants have any questions, you may ask Dr. Marcus now.
I think there was a first question that says, how do you engage with EPGC, through SWA or through specs? I think that later Jazz will share a QR code where the information for SWA and specs is available. We'll be most happy to work through SWA or specs to bring any potential visitors to EPGC. Of course, knowing the constraint of COVID and the government guideline as to whether we are in phase 2 going into phase 1 and eventually going back to normal, we'll be happy to offer any visit to visitors on a schedule that will be possible for all parties. So just write to us. I think Jess has a QR code at the end of this session with the contact information as well. So the second question was, is there any scheduled physical trip to EPGC? I think it's more or less the same question. We welcome inquiry to be sent to the SWA or specs email, for example, or you can call us so that we can organize group tour for interested party to, we can host you at the EPGC. Yeah, thanks a lot. I think Vivian has also said that because of the COVID restriction, right, until the government allows us to visit, we will be happy to do that.
Okay, thank you, Dr. Marcus. So any participants have any questions? I think there's a question just popped up from in the chat group now. Dr. Marcus, can you see the chat? It says, what's the status of floating solar PV for fish farms and EMS? Okay,
I think that you have heard recently that there is quite a few, I think Adrian probably know as well. Dr. Adrian Yeo has, through Sembcorp, there's been some potential deployment, and I think the award has already been given for floating PV. All right. So the freshwater story, I think, has already been announced for quite some time in our reservoir for floating PV. So now it's really going out into bigger scale in salt water. So I think that we are very excited that after all the past research and development now is reaching a real, not just deployment, but it's becoming commercial. So these are real business case that is being explored today. All right. I think we are happy to share that it is still work in progress, but at least we see that the opportunity is already out there for company to exploit different business model.
Okay, thank you, Dr. Marcus. So, and also I think Ravi have asked a rating of the system.
May I know which rating or which system, because I can't see all the chat, Jess, if you can help me a little bit.
Okay, sure. Okay, Ravi, if you're still there, yeah, he says, okay, back to Ravi's question, yeah, for the solar PV.
Okay.
Yeah.
I think that right now the floating solar PV easily can go up to megawatt scale. All right. I think that is already something announced in the news as well. So until more system is deployed, then we will be able to assess what kind of challenges and opportunity that will come along. Of course, there are several players already been proposing floating PV both in a freshwater and saltwater. But this is an exciting topic because once you start doing integration, implementation, connection, there'll be not just technical challenges, but includes regulatory challenges as well. All right, and this is something that Singapore is also learning. So there was a question asking, what are the potential application for the, I think you mean by the water energy nexus that would have motor regeneration. I think that one area that I can think of could be in a very simple one that is very close to us, which is the elevator that we take every day. All right, every time when the elevator is going up, it's actually motoring, but eventually you actually allow it to decelerate or going downwards, it could potentially be going into a regeneration. So there is an opportunity for energy recovery, for regeneration in that sense. So it's a very simplistic case, but of course there are more situation that we can describe and apply. I'm just giving a simple example, all right, so that is closely related to the general public. But if something more technical, we can address that more specifically to that audience that is asking that question.
Okay, thank you again, Dr. Marcus. Okay, that's a request from Jason Donovan. Yes, Jason, you will send the presentation and the video. You'll be receiving an email from us for a post survey on this webinar. Upon receiving your feedback, we will send you the link and you can get the presentation. And also to all the present today at this webinar, we'll be sending you a post-event survey form. So kindly send to us. Okay, I'd like to share with you our two upcoming webinar. The first one will be on the 22nd September. That's next week. That's unlocking the potential of wastewater, co-organized with the Embassy of Denmark, Singapore. And the second one will be on the 6th October, Tuesday. And this is PUB BIM e-Checker initiative. So please look out for our EDMs, and we thank you for your participation and support in this virtual visit. This is, sorry. Okay, so if you have any questions, do post to us. And also we have the contact details for specs. The email is below there. And please continue to stay safe and do look out for our EDMs for our future webinars. Thank you and have a good weekend ahead. Thank you, everyone.
Okay, thank you.